So yeah, what I'm going to spend, I'm writing a book at the moment, which you can actually, I've just noticed, you can see all of the chapters in Google Docs at the top. So I thought this talk is based on a few chapters from my book, which I thought would make it easy to write a talk. It turns out that there's too much to fit in to a 45-minute talk, so I'm going to try and stay really tight and like focus on stuff. If you want to know more, there's some links at the end and a free access pass to the O'Reilly platform. So I'm not sure this chapter is on the platform, but it might be in a few weeks. You can click on the link, get a free month to O'Reilly, and you can read the chapter and give me comments and feedback and tell me if you think it's good or not. But just like we said, the idea of this talk is there's a ton of things we can do with software, and lots of the stuff that Jutta talked about, and lots of the things that Kevin talked about, and lots of other things that other people talked about. But frequently we manage to not deliver it. So the idea of this talk is to figure out why and help people do that. But the reason why I'm talking about minimum viable alignment is because previously when we wrote software, we would build, like Kevin said, we'd build big monoliths. It was a lot more, the teams were smaller, we might be kind of more command and control type thing. Now we're building decentralized systems with typically decentralized teams, right? The idea is we're trying to do the Conway maneuver, not the inverse Conway maneuver, and make teams independent and things. So that's cool, but teams are independent, right? But how do we all stay pointed in the same direction? And what we see typically, and I see this a lot because I'm a consultant, we see teams that have tried to do this and they've ended up with all the pain and none of the gain. So the pain, things I've got a list because I forget it. Nothing's speeded up, everything's going slower. Everybody's got loads and loads of pain from increased coordination, trying to make sure that your pieces of the software work with the other team's pieces of the software. The problems got far harder to debug now that you need to like trace a problem through multiple microservices. The tech debt is everywhere because I'd rather write some code in my microservice than speak to Kevin and ask what his microservice does and do some design together. It's just got far more painful. And we're in meetings all the time to try and sort it out. And so that's what I'm hopefully going to share today in this talk. I'm going to talk about maybe nothing that's new. I don't think any of these things will be new to you, but hopefully I'm going to present them from a perspective of why you would care. One of the reasons why you would care is definitely to build in the sustainability stuff that Jutta talked about, but why you would care to make all of these things work together. So, just enough alignment. So what we're going to talk about, I'm going to talk about this space up here on the screen. So this space is like a virtual design space. It's where, when you're building systems, this is where you're building systems, right? So you've got a feature or something that you want to implement, so you've got to think about it, you've got to do some design, and when you're doing that design, there's multiple different ways you can do it, right? You could use different technologies, you could use different patterns from architecture, you could use different cloud platforms, etc. Each of those different directions has pros and cons, upsides and downsides. And what I want to do is select the best one of those options to fit my circumstances. And so I do that and I make my decision. Then another decision comes along and I need to, again, think about the different options. I need to pick one of those options, or we as a team need to pick one of those options, and we select it and we kind of move forward. And so I implement those systems, but that's not, again, like Kevin said, we're not done, right? We've now put these, hopefully we're doing continuous deployment or something, we've put these things into prod, these systems into prod. Now we're iterating again because we're like, oh, we've learned things from putting it into production. The system is evolving, the requirements have changed. As Jutta said, maybe we built stuff we didn't need, so we turned it off. So extra things are going into prod, and the learnings from that are feeding back into further decisions. So what am I specifically doing when I'm making these decisions? Number one, there's a user story, again, like Jutta showed, that would specify what it is. So there's some functional elements I need to make my software do, but I'm also deciding about other things. I'm deciding about what qualities the system will have when it's running. So things like how fast does it need to be, how scalable, how secure, how much compute resource does it need to use or not need to use. That's part of my decision as well. And I'm also figuring out how much I'm going to build myself and how much I'm going to rely on other teams or on other third parties for that software. All of these things are factors in the decision that I'm making. And that's what's going on. But also the key thing is, this is maybe just me in my design space, but you are in your teams making your decisions in your design space. But that's the next point. there isn't multiple design spaces. If we're all working for the same organization, then that design space is a shared design space, right? And even decisions from other organizations kind of impact on our design spaces. And that's what's happening here, right? So everybody's making these decisions and they're building all of these pieces of the software, and we're proceeding to create and build software. And that's what you can see here, right? There's more arrows representing more teams making more decisions to build their systems. And so there's something here it probably feels quite good because all the arrows are pointing in the right direction, right? That's kind of what you want to feel like when you're writing software. What we've got here is technical alignment. Technically, all of the different parts of the system are all aligned with each other. Another way of describing it is conceptual integrity. If I looked at one part of the system and another part of the system, it would make sense that this part of the system does this, and it makes sense. I don't need to know too much. That's what you want. But that's not everything you want. The extra piece that you need to think about, which is I've added here as a sun, because the star emoji, and I like using emojis for talks, the star emoji isn't as good. But this is what you want. You don't just want all the arrows to be kind of lined up. You want the arrows to be headed in the right direction, right? So this is the picture of the ideal world. They're all aligned, all your systems are aligned, you're all kind of conceptually doing the right thing, but you're also headed in the right direction. You're headed towards the direction that you want to get to, right? If you have this, you don't need this talk, you've already got minimum viable alignment, you can go back to sleep and catch up on your sleep. The thing is, I've never seen this happen. Actually, that's not true. I've seen it sometimes when startups come out of the tiny startup phase and they move into hiring the next 10 people, then it all goes wrong. So they go to scale up and suddenly it's more complicated. And that's what I'm going to talk about now. Because what I want to talk about is how to understand if you have this level of minimum viable alignment, because maybe you do and you're lucky, you just don't know it. Or if you don't have it, how to find it and how to evolve it, because that sun might move, right? Like Jutta reminded us, or like Jim reminded us with his question, what's good today might not be good tomorrow. So the sun might move and we still want to head in the right direction, so we need to change. So let's start thinking about how to begin with how you know whether you've got it or not. So this is what I see a lot. This is complete lack of alignment. I see this like all the time, especially if this is like my visual representation of if we move to microservices and our lives suck, can we stop doing microservices, right? So there's lots of teams, they're all independent, they're not working on one big arrow, they're working on lots of little separate arrows, but it's all complete chaos like this, right? And you know that it feels like this, so this is the representation, but the reason it'll feel like this is because you will hear people talking about their system or their decision or whatever they've just decided to do, and it will surprise you because it won't be what you expected them to say. They're like, oh, we just deployed to Azure. And you're like, I thought we were using Amazon as our cloud platform. Why are you deploying to Azure? So in the old days, some probably middle-aged white guy would come along and tell everyone what to do. We are doing this, and they were the boss, and they would tell everyone to do. But we're now all of us building complex systems. So top-down control, maybe someone can stand there and say it, but if you do that, then everyone still spends all this time coordinating and asking the top manager or whatever, or the architect, what's the right decision for this circumstance? Then you've lost all the value of being separate independent teams, right? So you've just put all of your teams back together, getting into one big team. So that's you can't do that, so you need another way of achieving it. So let's remove the North Star and just talk about technical alignment if you've got technical alignment. That means that the decisions of one team are aligned sensibly with another team. It means things like you're probably using compatible programming languages. Doesn't mean you have to use the same ones, but they can all work together. You're building microservices which can communicate with each other, maybe gRPC or something, but someone's agreed on the minimum level of communication standards. Or you've decided that you're all going to run in a certain runtime, which doesn't mean Kubernetes. Other runtimes are available, but you've picked that kind of thing. And the way you get to this is you typically have a lightweight governance process. So you've kind of got some process, which means that when a decision is made, some group or something, somehow people are coming together to kind of give feedback on this decision to say, right, this is good for you, but it's not good for everyone else, and maybe your arrow is going to go in a different direction. So this is good, right? This is not bad. Relative technical alignment, conceptual integrity is really good. But it might not be powerful enough, right? We might still be headed in a completely different destination from the one where the rest of the organization who we're building software for think we're headed, right? Where you end up could be somewhere very different from where you think you're going to end up, because you're just making sure you're not treading on each other's toes. You're not making sure that you're all headed in this direction towards the North Star. It's like maybe the North Star over here, right? But everyone's confidently building on Kubernetes, because Kubernetes is definitely the right solution for everything, right? So this is the question. How do you make sure that you, without sacrificing alignment and without having some big guy in the sky telling everybody what to do, how do you still maintain this kind of thing and so that you can get something like this? So this is what you want. But before I want to talk about how, I want to talk about what it looks like when you get this. Because again, you might have this, or you might have bits of this where you work. So I just want to kind of list out, when this is happening, what it feels like. So what does it feel like? It feels like you're writing software, and that software is getting in front of users and is doing something valuable for users. Because we were talking at dinner last night, I worked for 7 years before any software I wrote shipped. So if your software isn't shipping, then maybe there's a problem, right? So number one, seems obvious, but is your software shipping and is it doing things for people? But number two, like I say, realizing value. Realizing value means like helping your user achieve goals. It doesn't mean you've delivered the features. It means that the job that the user is trying to achieve is being assisted. Maybe it's your software getting out of the way, right? But that's one thing. Or, if we're bringing product thinking into it, you implement a feature, it doesn't make things better, it makes it worse, so you fail fast and you remove the feature, right? So feature toggles and stuff that you talked about. It also looks like moving at a sustainable pace. Everyone can build, again, startups build a lot of software really fast because there's very few people and they've got a green field to start with, but they can leave a terrible mess behind them. This is not the terrible mess, this is sustainably going, right? So you can implement new features without saying it's going to take 6 months to move that button. It's also having a predictable cost to run, because again, it's very easy to build software that can do amazing things, but if it costs millions of dollars per month, then that's maybe not sustainable for the business. And an acceptable risk, because again, I can do a load of stuff if I deprioritize making sure that I don't, take too much user data or expose too many things to the public or whatever, but that again is important to most organizations. And I'm able to continue to meet user needs. So all of these things, if you have all of these things, you're probably doing it. Maybe you're not aware of why you're doing it, but you're lucky that all of these things are happening. So if you are heading in these things, then it's far more likely that the sun will come round, or like you will rotate round and you'll be will be headed towards the sun. So what are the things that you need to have to be able to make sure that your arrows and your kind of the smaller internal arrow is pointing in the direction the larger arrow is pointing towards the thing? And I keep stressing this, but it's important. You can't go back to some one person telling everyone what to do, because we've changed how we write software, so that means that doesn't scale. So we need something that's collective and something that's not imposed from the top. It's something that kind of comes from the group and is continually evolved and shaped by the group. And when you get it, you get something like this. So when you kind of know it, you know that it's working. It's broader alignment. So the teams are aligned with each other, but the teams are also aligned with the organization. So that's the bigger arrow is pointing towards this North Star, right? And so, the reason this makes all the teams effective is because by doing this, it means you'll be far more likely to be able to achieve all of those goals, to make sure you're delivering value, to make sure you're appropriately spending money on the cloud, to make sure that you're appropriately taking the right risks or spending the right money to mitigate the right risks, etc., etc. So let's start thinking about how you make sure that you're doing this. And so the thing I started with was this design space. We're still in the design space. Every time you make a decision, and you could argue that software is just made of decisions, right? Decisions and the implementation of those decisions, and those decisions continue to be made all the time, all over the place. That's your software architecture. If we go back to decisions, that's how you make sure, that's when you're deciding which direction your arrows are going in, and that's when you decide if something is appropriate or not. So again, I will talk about how to know go in the right direction, but it's easier to tell you about when you're going in the wrong direction. So I'm going to describe some examples of how to know you're going in the wrong direction, because that will hopefully tune you in to what the right direction might be. So what you're looking for is, you're coming to a design, there's some point you need to make a design decision. You need to decide like whether, what pattern you're going to implement in your system, or how you're going to refactor two systems into two separate pieces or whatever. You'll have some design decision will come up. And at the point that decision comes up, there's typically 3 anti-patterns that I see, which give a good indication that something's going wrong, that you aren't headed towards the North Star. And those 3 things are duplication of effort, debating the same technical point over and over again, and favoring technical things, favoring enjoying talking about the technical more than talking about the functional. So let's look at each one and see why it means misalignment. So the first signal is when there's lots of debates happening, but the debates and the decisions that result from them are leading to non-differentiating effort. So for example, like I mentioned a minute ago, all of our teams are deploying to AWS, and then one team comes along and says that they're going to decide to deploy their new services to Azure. If there is a very valid business reason for them to do that, and I have seen this with clients before, then that's differentiating effort. It makes a difference. But if it's just because they did the Azure training, or because they went to a presentation at CodeCamp which told them Azure was cooler than AWS, that's not valid, because someone's going to have to come along and re-provision all of the work to help support the systems on AWS. Someone's going to have to port that across to Azure, right? If there's not a good reason to do it, that's waste. Or higher up the stack, maybe some teams have to implement some workflow, right? We always have to implement workflow. Maybe the organization already has a little piece of software or a little library which does that workflow, but that team decides to not use that library and they go a different way. Maybe there's a good reason for them to go a different way. So if there is, then that's differentiating. But if there isn't, then they've just deviated from the kind of shared path of everyone just because it felt like it was a good idea. So that's the first one. The second one is debating technical points over and over again. The one that I see, maybe it's because cloud's taking off, but the one I see with clients more and more is when we're building multi-tenant software as a service type solutions. So lots of people are building SaaS products. Nobody can agree on what the word tenant means. So you're a multi-tenant solution, so you've got multiple of these customers living on your system, but nobody can agree what a customer is. So you constantly debate what the customer is, right? Or you're constantly having a debate every single time someone creates a new microservice as to whether it's going to be event-driven or simple, like a RESTful service, or if it's CQRS, or if all these things. Again, it's a technical debate about exactly how our system's going to be built. All of these debates come from a clash of viewpoints. And again, like I said, they're not necessarily always bad, but what you want to do is make sure that the reasons for the debate and the outcome of the debate is selected based on the North Star, not based on what you think is technically most appropriate or most fun to build. But what I see a lot is people are like, we should definitely do Lambdas because everyone's doing Lambdas. That's not necessarily a great reason to do it. And then signal 3 is favoring the technical over the functional. So again, as software engineers, we love debating the cool technical stuff, which is cool, right? We need to be aware of what's going on. We need to be making decisions based on the most up-to-date technology that's available to us to do stuff. But when you're listening to decision after decision after decision being taken, and each of those decisions is always focusing on the relative merits of Lambdas on Azure versus Lambdas on AWS, or the different flavors of Kubernetes or whatever, and no one's ever bringing in the functional needs of the software, like, for example, lots of stuff that Jutta talked about, or lots of, like, what are we trying to do for the user? If you're focusing too much on the technical and under-focusing on the goals of the organization, the goals of the software, you're going to drift again. And so, to be very clear, the reason I know these signals are strong signals is because I've been that guy wanting to spend more time talking about Lambdas because it's more exciting than it is talking about onboarding customers onto my SaaS platform. Right? But they're all missing one thing, and I've kind of hinted at what the thing they're missing is. The thing that all these decisions are missing is not a technical piece of information. It's not an architectural piece of information, it's an organizational piece of information. It's like, where is the North Star? Where is the organization going? That's not technical. Even if you are an entirely technical company, you'll still have a goal and a vision of your organization which isn't, to do with something technological. So let's have two quick examples, because there's some examples that I've come across which are quite good, and they're actually sustainable, which is also good too. Because the same decision point can lead to different decisions based on where that North Star is. So there's a thing I've done a few projects with companies working with e-mobility and specifically charging systems and for plugging in cars to charge. If you have a lot of charge points, or if you have 3 charge points, you need what's called a charge point management system, a CPMS, to manage the fleet of chargers, right? To update the firmware and remotely start and stop a charge and all this kind of stuff. That's a standard piece of kit. It's so standard that there are open standards. I think there's 7 open standards which specify how these things work, how they communicate, how they talk to all of the different types of chargers, all of these different things, how they do security, everything. How they record the electrons, do the billing, all of these things. So that's standard, that's good, right? The industry has agreed that those things exist. But I've worked with 2 clients. One client wanted to have so little to do with their CPMS that they were going to go to a third-party SaaS. They were going to pay them to run for their service for a CPMS. They didn't want anything to do with the code. They didn't want to write any code at all. They were building things on top of the CPMS, which was easy because it was open standards based. So they could build a product on top of this other CPMS, which they didn't even see. It wasn't running on their service. They didn't have any code. That was because they wanted to have a service which was very tuned to their customer needs. It was going to be very, kind of high level of customer service, very bespoke. They wanted to get people who were thinking, oh, I don't want to have an electronic vehicle, it'll be too difficult. That was their target audience. Another client wanted to just spread out as much as possible and build as many charge points in as many places, in as many countries around the world as possible. So their aim was for scale and standardization. So therefore they wanted economies of scale. They wanted to build their own CPMS and control every single piece of it, because they wanted to be able to drive the standards, they wanted to be able to onboard new types of charger before anyone else. So they built from the ground up their own CPMS. So 2 companies with exactly the same need, we have to manage our charge points, had 2 very different decisions because of where their company was trying to go. So, if you have all of these things, what do you need to do to get this minimum viable alignment? So you don't get it from one thing, you'll get it from these 4 pieces. And that's the key thing, because what you need to do is have just enough to be able to inform all the decisions in all of the teams, and there'll be lots of decisions and there'll probably be quite a lot of teams, to be able to inform those decisions in those teams, to remind them of and help them point towards the North Star. And also, as those teams make decisions, they'll learn things, so they might be aware, they might notice that the star is moving, the sun is moving, so you want them to feed back into this decision system the fact that technology has changed or the direction of the organization has changed. So what we've got down the bottom is a structure to help teams be independent and work in this world. So we've got 4 different things. On the bottom left is cross-functional, which is what ThoughtWorks call them, or non-functional requirements, which is what the rest of the world calls them. And they are what help you make stabilizing kind of forces on your decisions. You also want to have a technology strategy, which is actionable. So I'll talk a little bit about how to have an actionable technology strategy. You want a knowledge sharing system so that you can not just tell people what the information is they need to do, but some kind of executable version of this. And you want a system that's the thing surrounding it. That's the piece that will kind of give the feedback to all of these 3 parts in the middle to feedback to make sure that this all works. So let's start with the first one, the CFRs. So the CFRs basically answer the question what. So the question what is, the organization, the business, the people who are kind of, probably providing the money for all of this are going to have a bunch of assumptions about how the software will run, what the software will do, what qualities the software will have. And so you can basically see the list of them. There's a standard list. What performance? Do they have expectations about how fast or slow the system will be? Do they have expectations about the capacity and scalability, the availability and resilience, the security, the laws and regulations? Lots of different things. Like I said, these are the types of non-functional requirement or the type of cross-functional requirement. The reason we call them cross-functional at ThoughtWorks is because they kind of apply across the whole system or across a large portion of the system. They're not specifically tied to one specific feature. That's a functional requirement, like a user story, right? But these are things, like if you don't write them down, they're still expected by the business. Like if you build a system that's slow and they expect it to be fast, then they're going to tell you, but it'd be nice to ask them before. But the other key thing is, you don't have to answer all of these questions. You just need to find out what the expectations are, and then you capture CFRs for those. So you don't want thousands of CFRs. You want just the right CFRs which kind of specify the key things, which is everyone's expectations about what the system will do. And the place to find out from is your organization, right? So your organization, the product, or the people who you're building things for will know. And then you want to capture them in a way that's testable and actionable. So here's an example from the EV driver thing. You could use the format, you don't have to, but this is what I use that Jutta showed before for stories. As an EV driver, I want the system to start a charge within 500 milliseconds so that I can know the charger's working. This is a thing because in Britain, not all the chargers work, but not all of them work fast. So if the charger isn't working, I want to get in my car and drive to the next parking bay. If it's just slow, then I don't know if it's just slow. So you want it to be quick. So that's the requirement, but that's not testable. So you also specify, using again a standard format, doesn't need to be this format, but you want to specify some key things about that requirement so you can test it. You can use fitness functions, which is another thing that some people use, or you can just get testers and QAs to test it. And these are the acceptance criteria. And the key thing here is the things that are underlined are the things that are common. So you will end up with quite a few of these specifications, and you'll want to say frequently using a normal operating mode or using a failover operating mode, right? You don't want to repeat every single time what that is in detail, but that could be a hyperlink to a page on a wiki which says this is what normal operating mode is. Normal operating mode is all services operating with N+1 resilience with no AWS failures or any of this kind of stuff, right? And you can do the same for all the things. So respond within 500 milliseconds. In detail, might have a statement which says 98% of all things will reply within 500 milliseconds, 99% will reply within 700 milliseconds. So you can give that detail of the fact that it's, as Kevlin said, it's a network, so it's not that predictable. You can be more specific and make it more testable. So I'll skip that quickly. So that's CFRs. So CFRs are the first set of things which take that North Star but turn it into things you can use to build software. They're the expected qualities that your system will have. So not the functional stuff, that's already in the backlog, but the extra stuff. But that's, that's what the system will do, but it's not agreement on how the system will do it. So we still, if you just had CFRs, you could still have loads of teams implementing the same CFRs in different ways, right? So that's the next piece that you want to take in, and that's tech strategy. So tech strategy helps everyone in the organization focus on their mission. So it helps prioritize things and it helps deprioritize things. And the things it prioritizes and the things it deprioritizes are specific to the mission and specific to the stage of your product and like where you are in your journey and like how much money you have available, etc., etc. And then these things in tech strategy can be used so that when a decision comes up, and I was talking about like the multiple options, these things should help you say, right, option B is better. They're all technically feasible, they're all similar, but we want to be super cheap, or we want to invest money because we know that this is key and we know our competition don't have as much money as us, so we'll do something more expensive. So let's look at what it means in practice. So this is the best format that I've seen. So tech strategy is something that all clients tell me they have and exists, and they can never send it to me. Or when you see it, it doesn't actually mean anything, or it's not usable by the people who are building the software, right? People like us. But if you do have tech strategy and it's articulated like this, so this is another good one. This is the kind of thing you'd want, right? So we bet, because we're betting, we're looking into the future. We don't know, right? It's not that predictable. But we're betting that by using our own in-house LLM, by doing all that investment, which was talked about this morning, right? It wasn't cheap to put all of that stuff in place, but we bet that by using that instead of some third-party one like ChatGPT, which we get off the shelf, we'll be able to offer something unique to customers despite the additional time and effort, right? So we know it's going to take longer and we know it's going to take more money, but we're still doing it because it's strategic, right? So that's the kind of thing you'll see for tech strategy, but tech strategy can have different forms. So two key forms is it could be quite small, and remember the slide is like the design space, so it can take up a lot of the design space and tell you quite explicitly, or it can take up a small amount and give you a lot of freedom. So the small one is use AWS, blah, 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 because it's cheaper, AWS. But so that's quite small, right? Or it can be super, and like different clients have different things, right? Or it could be use AWS, but only these primitives in the AWS suite of offerings. And by the way, you've got to use our Terraform templates, right? So don't go to the UI and click through and set up your own stuff, right? So they've taken up more of the design space. There's things you can't do. You can't use Lambda because someone's said. Or you could, but if you did, you'd have to write an ADR, which would say, we're using Lambda because even though it's non-strategic, it lets us do this thing. Also, strategy doesn't have to say the same answer for all questions. So strategy here could be, say, use COPS on EC2 for certain types of workload, or EKS for certain types of workload, or even maybe Lambdas for certain types of workload. So it could specify different options and different things. So that's strategy, but strategy is just words, right? So it still means that I need to implement my pieces of the strategy, Jutta has to implement her piece of the strategy. That feels like waste again, right? So then you can also take the next thing, which is strategic investments. You can say, this is strategic. We've all agreed. We think it's a good bet because it's headed towards the sun, towards the North Star. So let's invest money to build this stuff, right? And there's different levels. So level 0 is what we've got. It's somebody saying, please do this, or everyone agreeing, please do this, right? Let's all use AWS, but only use MSK and EKS. But you can spend more money, right? So the next level is speak to this expert. There's somebody who's got some time in their day put aside. So for example, you've decided to use Gradle. Gradle is very good, but it can make everyone's lives horrible. So you've got, someone has noticed that there's a benefit to Gradle, but it's slowing everyone down unless we invest in it. So then there's an expert who you can speak to and they will help you fix your Gradle build when Spring upgrades and everything breaks. The next level up is they will set your Gradle build up for you and they will fix it when it breaks. So it's the same thing, you're still using Gradle, that's the strategic direction, but now you don't have to do it yourself. And then the final level, self-service, this is you press a button, it automatically generates you a pipeline with all of the standard stuff set up, so it's doing all of the standard steps to meet all of your CFRs, right? Because what you're trying to do in your build is make sure you scan for certain vulnerabilities and make sure that you're not using the wrong open source licenses, etc. So it's doing all of those things. If this sounds like a platform, which is what everybody loves talking about these days, this is a platform, right? A platform should be strategic. It should help you do the things that you want to do. Loads of people build platforms because someone in management thought it'd be cool to have a platform, and it's automating things that you don't care about. Whereas you hate having to fix your Gradle build all the time, and if someone could just make that easier, then it would be good, right? And so that's the last part of the structure. Because the last part of the structure is how do you know where your strategy, you've done a good guess, right? And I'll talk about, there's two parts to this last thing. What you want to do first is with the principles is look at, as a group, sit down and say, these are where our organization thinks it should go and this is what we think our direction should be. How does that turn into things which will help us write software? Then you'll use that to help you make your decisions, right? You've got a decision, you've got 3 different options. Those principles should help you make a decision. Option A is better than option B. But then you'll build those things and you'll learn, so you want to close the feedback loop, and that's where the tech radar comes in, which is the thing that closes the feedback loop. The combination of these 2 pieces of information feed into your strategy and feed into your strategic investments. So let's see how they do that. So on the left is, and this is described in the book, this is what I didn't have time to talk about, but on the left is a structure for a workshop, which I actually took from another book. So it's called The Art of Scalability, and I took bits of it and kind of changed it a little bit. But it says if you take your overall organizational strategy, break it down into 3 themes, so they want to be product leaders, operationally excellent, and have customer responsiveness. So they broke their tech strategy into 3 themes. Then they crowdsourced from all of the development teams principles which the teams thought would help be product leaders, be operationally excellent, be customer responsive. They mapped them onto this Venn diagram to make sure that they had good coverage of all of the different types of things. And then when everyone agreed, they picked between 8 and 15 of them, and they turned them into this principle. And each one of these 8 to 15 turns into one of these things. So cloud native, when we say cloud native, it means our cloud. So that helps people make decisions, etc., etc. Better speed up. That's things that are going to help decisions, but what about the aftermath of decisions? What about after things have happened? So you might have heard of the ThoughtWorks Tech Radar, which is kind of famous. The new version, I think, came out last week or is coming out next week. If it hasn't come out yet, then that's a sneak preview that it is coming out. What people don't realize is you can build your own Tech Radar. It's just a gigantic Google spreadsheet. If you go to the website, you can click on the link for Build Your Own Radar. It gives you the link to your own spreadsheet. You can capture all of the frameworks, all of the languages, all of the practices or anti-patterns or whatever, type them into the spreadsheet, and it will render your own Tech Radar. Just like ThoughtWorks, you can keep running this once every 6 months or once every 3 months, capture the feedback and see who's using what. Do you think it's a hold because everyone hates it or you don't want to use it anymore? Do you think it's a trial because 2 teams are trying this new JavaScript framework, etc., etc.? That kind of sensing from the feedback of all of the teams trying to build this software will help you align to what's going on, and then you'll be able to feed that into your strategic investments and tech strategy, etc., etc. So to summarize it quickly, because I think I'm just at the end, we started with what, right? So that's the cross-functional requirements, right? They're the minimum shared expectations that everybody has across the organization, not just in technology, about what your systems are going to do. That's your CFRs, right? They capture the mission and they turn it into these expectations for your software. The rest tell you how everyone's agreed you're probably going to do it, right, with these feedback loops. That's a minimum shared agreement as to how we're all going to make sure we point towards the sun. There's tech strategy, but then you make it actionable by building strategic investments, by investing money in people and software, and you use the principles in Tech Radar to make sure that you're constantly sensing and reorienting. What you're doing by doing this is you're creating not a set of artifacts, but you're creating a shared mental design space, right? And I mean it when I say if an architect comes up with this on their own, it's going to fail. But if the team, if you all sit down and contribute to this, by contributing to it and evolving it, then you'll manage to build it up. And that then lets you have impact. And that's the message I want to leave with. Because if you want to build software that actually has an impact and is of acceptable risk and a good cost and delivers on like green goals and all of those kind of things, this is a really, really good way to do it, because I've set this up lots and lots and it works really well. So that's the thought I'd leave with you. That's why you care about this, hopefully, because it helps you make sure that all the software and all the code you write is delivering in a direction which works. Thanks very much.